Hey, this is OXDF, and we're back looking at day 15 of the 2015 Advent of Code again. I did a whole video solving this. If you want to go check that out if you haven't watched that already, but you don't need to have seen it to see this. Basically, what we're doing is we're looking at a solution where I provided double for loops, so like nested for loops on to get to where I wanted to be. And I mentioned in the video, I think, that I was hoping I could just do it all with chained functions, but I wasn't able to get it to work. And since that video, I talked to Epi, my friend of mine who's a very good Rust developer, and managed to work through some of the ownership issues I was having and got it working with just a single, where I had two nested for loops and then some if statements. Now in a single line of chained functions, can get to the same results for both part 1 and part 2. So I thought that was pretty cool. It produces some kind of ugly code, and I'm not sure you'd actually go this route if you were writing this code, but if nothing else, it's at least fun to take a look at. So I wanted to show how I got there. So that's where we're gonna go today. Let's start by taking a loop at the loop and just doing a quick review of what we did. So this is the loop right here, and what they sort of, okay, so we start with these kind of best score markers, and that's just because as we loop through, we're going to be keeping track of which one's the highest, so we just need to start something at 0. And really we start with this self ingredients keys combinations with replacements 100. And what this is going to do is going to generate a vector of vectors of strings. And so you can see that here in when it says com is a vec of strings. An example here, if I did combinations of replacements, like just as 4, for example, I might get a vector. One of them might be candy, candy, chocolate, butterscotch. And so we're going to have all the possible orderings and combinations, well, not orderings doesn't matter here, combinations of different numbers of each kind of thing with a total of 4 or 100, depending on how we set it. So we're going to loop over all of those. And so each one of those is going to be a possible, recipe that we're working with. Now for each of these, we're going to initialize a new recipe object, and then we're going, or a new properties object, we're going to call it a recipe, and then we're going to loop over. So we're going to pass this, candy, candy, chocolate, butterscotch into dedupe with count. And what that's going to do is going to change candy, candy, chocolate, butterscotch to 2 candy, 1 chocolate, 1 butterscotch. Which now we could just loop over each of those strings and add them together. That wouldn't be that hard, but it's nicer. It's easier to think about, at least in my mind, if we'd make it, 2, 1, 1. We can do that in now 3 loops instead of 4, or when we're doing with 100 with like 5 ingredients, maybe it's just 5 instead of 100. So for each of those in the loop, we're going to add those qualities to the recipe. And then at the end, we're going to just calculate the score for the recipe. We're going to compare it to the best score. For part 2, we're going to see if it has 500 calories exactly. And if so, then we're going to compare it to the best 500 calorie score. And then we're going to return these 2 best scores at the end. So now let's try to build this out chained. And what we're going to do basically, actually, we'll do this. We'll say this is equal to self, and we'll say looped is a Boolean. And then we can come down here and say if looped, and then we'll put all of this in tab, and now we do that. We can do else and come down here, and for now let's just do so we don't get yelled at by the checker. It's not a Boolean, it's a bool. So we're good there, and now we need to come down here to where we call it, say best score false, like that. And now looped is false, and so this should run exactly like I used to. Cargo run release, and we're doing release because this is a time one. So so if we loop false, we get 0. If we loop true, we should get our normal numbers. There we go. Okay, so we're happy so far. So let's start trying to recreate this loop, doing the same thing we kind of did before. So we're going to start off exactly the same as we did. We need to get the self ingredients keys combinations with replacements, and I'm going to start just for the sake of making this look nicer. We're going to start by putting all this stuff here. So we get this, and let's say let x equals At the end of the day, what we're actually going to do is we're going to take this semicolon off, and we're going to get rid of 0, 0, and we're just going to make one long statement that returns. But for now, we're going to say let equals because it allows us to see what we have here with the plugin helping us. So now we've got our combination of replacements, which is going to be that same candy, candy, chocolate, butterscotch we had before. Now, we need to do something to each item. We have an element. We have like when it's 100, we have a pretty long array here of different things. We want to change each of them into this dedupe with count, so we get the new format. And so what we're going to do is we're going to apply a map. That's what map does. And so we're going to take a combination. We'll call it C, and we'll say C dot iter, because we need an iteration, and then we're going to do, go here, we'll do dedupe with count, and let's save this and see what happens. Oh, we got to get rid of this. I guess we got to move to the end, this thing here, so we do that. And so we're going to get some errors here. And this one I got stuck on for a while. And this is actually where I was stuck when I was making the video, and I was talking to Epi, and he was like, gave me a hint here. So let's see what's our error. Let's just cargo run it. So C is borrowed here. We're having borrow issues. And normally I'm really scared of borrow. I'm scared of taking ownership of things because usually it leads to borrow things in the future. But actually, this is a case where I actually want to use a function called into_iter. And into_iter is going to just take ownership of C right here. And the reason this is good is because I'm not using C anymore after this. I'm passing it to this iterator, and I'm done with it. So I can take ownership, and I can throw C away because I'm only now using the result coming back from this iter. I'm going to take that and pass it to dedupe with count. I'm only going to worry about the results coming back from that. Like, I don't need these things down the line. So taking ownership there is actually useful, and you can see it solves our problem. So now I've got each object. This is, if we go, let's see, let's do it. Let's add another thing up here. We'll do total vol u size. And so we're going to make this, let's not do it here. Let's change that back. I'm just looking for a way. I want to be able to sort of demo this. And so what we'll do is we'll come up here and we'll say, let total vol equals 4. And now we can come down here and we'll say, total vol. And so now we can say, instead of making this 100, we'll make this total vol. And so we can now, because I want a much shorter thing, it would be a lot. So we can say for y in x, print line y. Oops, not that. Debug print. Right, let's see if that'll work for us. Because what I want to do is I want to see if we can show what that looks like. Is that going to error out? No, it just doesn't do anything. Oh, probably in the old looped equals true. Let's make that false. We don't really need to work off that for now. And so here we go. We're getting our iterators. We can, want to see that because it's an iterator, it doesn't print very well. What we can do is we can do collect. We're gonna have to tell it to the vec. Try that. And so here we go. Now you can see what we, again, for our toy example, we've now got we're now getting each line. So X is going to be this long array, which starts off being chocolate, chocolate, candy, or candy, candy, chocolate, butterscotch is now 2 candy, 2 candy, 2 sprinkles or whatever, right? Okay, so we're happy with that. The next thing we need to do is, okay, we want to now apply each of these for each of these. So when you have this vector here, what I really want to do is make a recipe, apply 2 sprinkles, apply 2 candy. And so what we're going to do here is we're going to come down here and we're going to do what's called a fold. And I went into this a little bit in a previous video. Oops, that's not quite the right place. Let's take that back. We're still doing this on each object in for each C, right? We're still doing it on each vector of strings. So we want to be inside here. We're going to come here and do our fold. And the way what fold does is it takes 3 things. First, it starts off with some sort of initializer or something like an initiation. Then I guess it's 2 things. And then it's a function that returns that updated initializer. So let me show you. what we're going to do in this case is we're going to actually make a new qualities object. Not qualities, why do I keep calling that? A new properties object. Like that. So now we have a properties, that's our initialize that properties. And now we're going to take in mute recipe. So now we take in the accumulator, and then we take in each item in the array. And so in this case, the item is going to be a tuple. And so we're actually going to take a tuple here, and we'll say num, comma, ingred. Okay, so now we've got, that is what's passed into the function. And now the function itself is going to look like, we're going to do recipe dot add self dot ingredients dot get ingred. Is that good enough? Do we have to probably unwrap that? Comma, and the recipe also needs a number. We'll pass it a number like this. Let's see what that looks like. So we're gonna get some errors. Let's see what we got. This is no longer valid. Let's get rid of that. What are our errors here? Let's run this. Call this must be modifies in place. Expected a string properties found a nothing. Ingredients get ingredient. Oh, okay. So what happens here? This function, we're taking in the rest of the iterator, which in this case is our properties object, and our, each object in the array. This needs to return the iterator. So what we're going to do here is we're going to update it, and then we're just going to add recipe. So that's where it was expecting a properties object and it found nothing. So let's try again. Let's see. So this is expected in I64 found a U size for number. So I guess we can just, that is I64. That might be dangerous if we get huge numbers, but we're not going to get huge numbers. So we're okay. I think we're okay there. Expected a struct properties found a pointer. So let's, we can actually dereference that, but I think the other thing we could do, well, we can do it for now. Let's see. I'm guessing we're going to still run into ownership issues, and we're going to end up cloning this. Yeah. So it's a move. So let's come over here and clone this. And now it's, I don't think we might, properties cannot be dereferenced. So when you clone it, it actually creates a new, you're no longer a pointer. Now you don't need that. And it works. This is cool. Now what we've done is we've created each recipe. We said we've gone over, in fact, we can look at our, let's look at our, for Y and X here. X is now, we can now see an iterator of properties. So we're now iterating over a list of properties, and that's our recipes. So we now have our properties. Let's see if we can, I wonder if we can print this like this. Does that work? Let's try it. And so now you can see these are each of the, we've gone from candy, chocolate, butterscotch to 2 candy, 1 chocolate, 1 butterscotch to here's a properties object, which has the sum of all of the properties for each of the ingredients in there. So we've already summed those all together, and we've done it all in one line here. So that's pretty cool. Okay, so now, make this a little cleaner. There you go. So now, how are we going to take, we got this thing, we really want to know is, we got to get 2 different maximums out of that same thing. So we could run this whole chain twice, but that's not, or we could save it here and then run 2 different maximums, but I want to see if I can do this in one line, right? So now we're going to say, okay, we're going to do another fold. And this time, now we're folding over each of these properties objects. So what are we going to start with? Let's start with, just like we did up here, where we started with 2 zeros as our kind of score 1 and score 2 minimums or starting points. We're going to do the same thing here. We're going to initialize a tuple as our starting point. And so we're going to take in our iterator, which will be part 1 and part 2. And we're also taking in each object or recipe that we're looping over. That's going to be these things. And what are we going to do for each of them? I don't know exactly where this is supposed to go, but we'll put it there. So for each of them, we're going to say, so figuring out the P1 score is pretty easy, right? We're just going to say for each of them, we're going to compare the iterator to like P1, what's passed in from the accumulator, to the new score of r.score. And if it's bigger, we're going to take it, right? So we can say like max P1 comma r dot score like that, and that will give us, in fact, like we can just do max p2 r dot score. Now that's not good. That's not going to work, but we've got a, we've got something here. Go ahead and get rid of this for loop because we don't need it. So what we've done here is now we said for every object, we're going to start with 0, 0, and then each object we're going to be comparing p1, p2 to the object, and so we'll just update the iterator where it makes sense. Now in this case we're doing both the same, but I think we may even be, if we look up here, X is now getting an I64. We've now taken this, started with this ingredients list, and we've gone through and we've completely distilled it down to 2 ints. So we can even just get rid of this at this point and see, whoa. What is going on? Let's see. Let's run it. I don't know. It's too much error here to figure out. Expected that, found that. Oh, because we don't need. Let's get rid of that. There we go. So now we're just returning whatever this I64. And so we run this, we get 0, 0. Let's see, what are we messing up here? Well, for one, let's put our size back to 100. And boom, that is the part 1 answer. So now all that's left to do is figure out how to get a part 2 answer. So let's come back in here and let's do let p new p2 equals, and now we want to basically just say if r dot calories, let's try that again, r dot calories equals 500, r dot score else 0, and that gets a semicolon because we're just ending it. And so now we can come down here and we can say, what is the max between not r dot score for p2, but new p2? Save that. And so now each time we're going to figure out, do we care about a new p2? If not, let's just give it a 0. And so now we can run it and we get 176 blah blah blah. Let's try this real quick with where is, I should have put this somewhere else. Let's make this true and run that. And you can see that we got the same answers. Hey, sorry for the kind of sloppy cut there. I went down some tangents of playing around with performance to see, comparing the initial for loops versus the pipelines. Epi had sent me some links about how in some scenarios that can be way faster with the pipelines, but it ended up not actually panning out, and the video got a little just long and out of control, so I cut that off. I will just say in this case it runs about the same. So with that, hopefully this is interesting. I really appreciate you sticking around to the end. That is a great way to show support. Hopefully you've learned something along the way, and I'll talk to you next time.